Hello, in this video I'm going to show you how to turn a CT scan into a 3D printable heart model. We'll go through the full workflow, starting with raw DICOM data, segmenting it in 3D slicer, cleaning it up in Blender, and preparing it for SLA printing in PreForm. So let's begin. We first add the data from the directory, and then we move on to the segmentation step. Here we navigate to the segment editor, we create a new layer, and we can name it model. We select our desired color, which in this case is red. To start segmentation, we use thresholding. Thresholding is based on Hounsfield values. After thresholding, we visualize the model in 3D by pressing Show 3D and clicking this button here. Now we can see the 3D model. However, as we can see, the model includes unnecessary parts such as bones, which we will now need to remove. For cutting, we use the scissors tool. By clicking and dragging, we can select the area that we want to cut. This process is repeated for the entire model, and we can include some more detailed cuts as well. This is the model after cutting. Now we need to smooth it, then hollow it out, and finally export the STL file. For smoothing, we press here, we scroll down and select closing small holes as the smoothing method with a kernel size of 4 millimeters. This can be changed based on preference, but we found 4 millimeters to be optimal. And then we press apply. To hollow the model, we select outside surface, set the shell thickness to 2 millimeters, and press apply. As we can see along the edges, the model has now been hollowed. Next, we export the STL file for further processing. We go to segmentations, select our model, scroll to the export to files, make sure the directory is correct, select STL as the file format, and press export. Now we are in Blender, where we will import our STL model. So firstly, we remove the defaults. Then we go to File, Import, STL. We select the directory where we saved our model and import STL. You may notice in your case as well that the model appears here, but it doesn't appear in the origin. So this may be that the origin of the model is defined somewhere else. So if you want to bring the origin of the software and the origin of the model to the same place, we right-click, we set origin to center of mass. Either surface or volume is fine, but I'll select surface. Here we can see where the origin of our model was, and we need to input 0, 0, and 0. Then when we click, we'll see that the model appears in the origin. Here we can see our model, but as you can see, it has some suspended parts around it. So these could have been cleaned in 3D Slicer using the scissors tool, or there can be some residues which we can clean up in Blender. So to do initial cleaning of the suspended parts, we select the model, go to edit mode, then we go to mesh, separate by loose parts. Now all the suspended parts appear as separate objects. We unview the original model and then we are left only with the rest. We select the first one, scroll down, select the last one, right click and delete. So now we have only our model left. We can go back to object mode and we see only the model without any of the suspended parts. We have removed the suspended parts, but we'll need to do some further cuts here for surgeons to be able to visualize the inner parts of the heart a little better. For this, we will again go to edit mode. This can also be done by pressing the tab key. Then we press A to select all. Then we go here to the knife tool, and while clicking and holding the left key, we see there will be another option appearing, bisect. We will select it. And we need to bisect along the line that we want to cut. So bisecting will cut through all the selected parts. So if we don't want a particular part, we need to make sure the line is placed in a way so that the suspended parts are not part of the line. And I will put it like this. Now we see our bisect. Here we see a small menu coming up at the bottom called bisect. Press on it. We select clear outer. And then we select fill. What the fill selection does, it makes sure that the openings are filled. Otherwise, they'll be left open because the model is hollow inside. And clear outer deletes the part, any part which is outside of this line. So after this, we need to cut along the other side as well. So for this, we will rotate the model. We can go to object mode for better visualization. The next cut will be along this side. Again, I will press tab to go to edit mode. And now I will go to bisect. And I want to bisect in this way. And I'll make sure that the aorta is not part of my bisect. I do it like this. And now we wait until the menu appears. And we again select clear outer, fill. And again, we see it was successful. So we've cut the two big sides now. And they were quite an easier cut because now when we want to cut this side, we can see that if we just do bisect, it will also cut the aorta. And if we view it from this side as well, we can see why, because they are on the same line. So what we need to do, again, we go to edit mode. We select all. But now we need to unselect the parts which are in the way of the desired cut and the parts that we don't want to cut. So for this, we go to selection box or select box. And while pressing and holding the control key, we select this. And as you can see, it unselects. So this we need to do for all the parts that we don't want to cut. Once we are done with all the unselections, we can go to bisect and we can again see our imaginary line. This is the way I do it. Now, because the line is towards the model, we need to cut the part which is in the opposite direction of the line. So this is why I will clear inner. And again, I will select full. We make sure it is how we want it. And we can see that this time the aorta was not cut. Now when we are done with bisections, what we can do now is we can just look at the model in object mode, make sure everything is correct. And here we notice that we have another suspended part, which we can again remove in the same way that we removed the suspended parts we did earlier. So edit mode, mesh, separate by loose parts. There can be other loose parts from the bisections as well, which we can get rid of at this point. We can unview the model, and then here we can see some small suspended parts. Once again, select the first one, press shift, select last one, which selects all of it, everything in between, right click and delete. So now let's go back to object mode again. We are only left with our model, which we now plan to print. So to export the model for 3D printing, we need to export it again as an STL file. For that, we do File, Export, STL. Again, we can go to the same directory and we can name it as Model for Print. This is just to remind us that this is already the process model because the original one is also with an STL extension. So we can now export this STL. And here it says that the file exported successfully. We can also save the Blender project file in case we might need this. We might need to make edits at a later date. So we can name it model. Now we are in PreForm software. This is where we will prepare our STL file for 3D printing. Firstly, we must make sure that the printer and material are all correctly selected. We use Form 3 Plus SLA 3D printer, and as a material we use Elastic 50A version 2. The layer thickness is 0.1 millimeter and the print settings are selected as default. We apply this, we go to File, open model for print.stl. So there's a warning. We can ignore this because by broken models, the software is referring to the intentional cuts which we made. We want to keep these. We don't want to repair it. So for now, we can just ignore it. Now we see the model, but this is suspended in air, not supported yet. With the red, we can see possible errors because it does need the support. We'll add it, but before adding the support, we need to orient the model on one of the sides that we've cut. So I click on the model. Here we see 3 circles, or 3 colors at least, red, green, and blue. Each one becomes a circle when you hover the mouse over them and is responsible for rotation in one axis. So let's rotate it like this. Now I'm just trying to bring it to the side here. Now it's on the side that I want. Here we see results of auto support generation, while the internal supports on the model were disabled. This we did to avoid internal supports in order to improve visualization of the internal parts. To add the manual supports in only the areas that we really wanted, we need to re-enable internal supports, which we previously disabled. Then we go to manual placement. Now, by the red, we see only the areas which need to be supported. Here you see 2 shades of red, one really vivid one, and then some other shade of red. The part that we shaded with red is not critical. It's not fully supported, but it will print. It's not too critical. The critical parts are these vivid red parts, which we do need to support. So for an example, let's start here. Here we see by the blue area the possible support it will generate, which will really be easy to remove. We will select the possible support location, press click. By yellow, we see the support was added, and now it's calculating the printability. As you can see, the red is gone from the side now. Now we need to do the same process for all the red that we can see. Now, as you can see, we added all the necessary supports and we made sure that no vivid red unsupported parts are still present. So to generate the structures for which we manually placed supports, we press generate structure. Now we can see that anything that we added manually are added to the model. We can check estimated time now. It'll take 17 hours and 3 minutes. It'll take 198 milliliters of material, of which 113 will be used for the model, 79 will be used for support, and 5.65 for the raft. And as you can see, the printer is currently busy printing another file. We can either connect to this printer, or if it's not connecting, we can add another printer. We can then just go to add printer and add in the IP address for the new printer. But if we want to use the current printer, we can just upload our model to the queue, and that completes our workflow. Thank you for watching.